Welcome to True Projects. In this video, we are going to see transfer learning for an automated detection system of fractures in patients with maxillofacial trauma. Introduction. An important development in medical imaging is the introduction of an automated fracture detection system for patients who have suffered maxillofacial trauma. If left untreated or detected late, facial fractures can result in serious complications. The accuracy and effectiveness of fracture detection can be greatly improved by utilizing transfer learning, which makes use of pre-trained deep learning models. The goal of this project is to investigate how transfer learning might revolutionize and how maxillofacial trauma is diagnosed and treated, ultimately leading to better patient outcomes and healthcare delivery. Objective of the project. This project's goal is to create a reliable and precise automated detection system for foretelling skull fractures in patients who have suffered maxillofacial trauma. The project aims to implement transfer learning using a pre-trained ResNet 50 model on non-medical images by leveraging the power of convolutional neural networks. By doing this, the project aims to improve maxillofacial fracture diagnosis and management, improve prediction accuracy, and reduce overfitting risk brought on by scan image limitations. Requirements. These are the requirements needed to execute this project. Hardware requirements. Operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is Upload Skull Fracture Dataset. Using this module, we will upload skull fracture CT scan images to application. The second module is Preprocess Dataset. Using this module, we will read all CT scan images and then resize to equal size. Normalize all pixel values and then split dataset into train and test, where application uses 80% images for training and 20% for testing. The third module is Train ResNet 50 CNN model. Using this module, we will train ResNet 50 transfer learning with CNN by using above train and test data and then build a prediction model. Convolutional neural network is a deep learning algorithm specialized in image processing. CNNs identify patterns, edges, and features in CT scan images to detect fractures accurately. Transfer learning leveraging a pre-trained ResNet 50 model enables the CNN to inherit knowledge from non-medical images, improving fracture detection accuracy with limited CT scan data. The next module is Accuracy Graph. Using this module, we will plot ResNet 50 transfer learning CNN accuracy and loss graph. The next module is Predict Fracture from Test Image. Using this module, we will upload test image and then CNN will predict whether image is fracture or non-fracture. Execution of the project. To execute this project, first we have to open the code folder. This is the dataset folder in which I have CT scan images stored. This is the model folder in which I have .h5 files, pickle files, and numpy files. These files contain the algorithm information. These files can be loaded into the project code during runtime to utilize the trained models. This is the test images folder in which I have test images. These are Python main code files. This is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload Skull Fracture Dataset button. A dialog box opens. Select the dataset and click on Select Folder. It confirms that the dataset is loaded. Now click on Preprocess Dataset button. So this is the preprocessed sample image. Close this image and now click on. In the text box, we can see total images found are 305 and these images are classified into fracture and non-fracture, and the dataset is divided into train and test splits in the ratio of 80:20. And now train set includes 244 records and test set includes 61 records. Now click on Train ResNet 50 CNN model. So we can see the model building here, and we can see the confusion matrix. So these are true positives and true negatives, and these are misclassifications. Close this graph. In the console we can see the model building, and in the text area we can see the accuracy, precision, recall and an F measure of ResNet transfer learning algorithm. Now click on predict fracture. Now click on accuracy graph button. So in this graph, on x-axis I have epoch and on y-axis I have accuracy and error rate. So we can see for every increasing epoch, accuracy is also increasing, and for every increasing epoch, loss is decreasing. Close this graph and now click on predict fracture from test image button. So these are all the test images I have. Select any of these images. I'm selecting the first image and click on open. So in the blue color text we can see image predicted as no fracture. Close this image. Now we will select another image this time. So I'm selecting the 8th image. Click on open. So this time the image predicted as fracture found. Close this image. Click on exit to exit from this tab. The conclusion here is the automated detection of fractures in patients with maxillofacial trauma using the pre-trained ResNet 50 model successfully illustrates the effectiveness of transfer learning in this project. The CNN-based fracture detection model achieves high accuracy and minimizes overfitting problems by utilizing a smaller dataset of CT scan images and combining it with the potent features learned from non-medical images. Due to the system's effectiveness and precision, it is a useful tool for helping medical professionals identify skull fractures, ultimately leading to better patient care and outcomes.
Thank you for watching video. For more projects please visit our website www.trauprojects.in. For updates on latest project videos, please visit Trau Projects YouTube channel and subscribe.